Hello everyone, in this video we are just going to study in detail about arithmetic operators in C language. Let's get started. So basically operators in C language are most widely useful for performing any kind of operations, and there are varieties of operators available in C language. Those are based on three major categories. One is unary operator, which requires only one operand for proper operation, that is at least one operand for operation. And the second one is binary operator, which requires at least two operand for proper operation. And another category is ternary operator, which requires three operands for proper operation. And among these, we are just going to start with binary operators, that is arithmetic operators, in this video, and then we will be continuing with each and every sections of operators like relational operator, logical operator, bitwise operator, assignment operator, ternary operator and unary operator one by one in future videos. So basically arithmetic operators are operators which is most widely useful for performing basic mathematical calculations in our program, that is addition, subtraction, multiplication, division and modulus. So these are the basic arithmetic operations that can be performed in a C program. So now I am just going to declare two different variables, a is equal to 7 and another variable I am just going to declare it right over here, that is b is equal to 5. And again I am just going to declare another variable c and I am going to assign it the value 0. And here as soon as I complete the declaration and definition of all these variables, I am just going to write c is equal to a plus b. So the result of this expression will be very simple, that is a and b's variables will be added and the result of that a plus b will be stored in the variable c. And here I am just going to print the c value. C is equal to percentage d c. Now I am just compiling this program. The compilation is successful with 0 errors and 0 warnings. I am just moving into the debug session of Keel Microvision IDE by clicking on the start debug session. Remember, I am just simulating the program. I am not dumping the program to the microcontroller board right now. So now when I execute this program line by line, let me just keep breakpoints for all the lines available right over here. You can see the program has reached the first line, that is int a is equal to 7. So that is nothing but move s r6 7. So the value 7 will be moved to register r6 as soon as this expression is executed. But it is not executed currently because we have placed the breakpoint before the execution of this line. I am just moving to the next line. You can see the r6 is loaded with value 7. And now the next expression is nothing but move s r4 comma 5. Which means the value 5 will be loaded to R4 register. You can see the R4 register is loaded with 5 and R6 register is loaded with 7 from the first declaration. In the next, as you can see here, R5 is loaded with 0, which is C variable right over here. And as soon as you come to the next expression, that is this one, C is equal to A plus B, that is nothing but instruction of add S R5 comma R6 comma R4. Which means add R4 plus R6 and store the result to R5. When I execute this, you can see the R5 will be loaded with the addition of A plus B, that is 7 plus 5, 12. So 12 is nothing but C in hexadecimal. So the value C in hexadecimal has been loaded with R5 register, loaded in R5 register. Now when I execute the last printf statement, C is equal to 12 has been printed. So this is how a basic addition operation will be performed inside a microprocessor. And in a similar manner, the subtraction, division, multiplication also happens. Let me just test all these one by one in a single program. I will show you each of the operations right over here. Here I am subtracting these two values and I am printing it. This is sub, this is add, this is multiplication, and I am dividing, division. Here I am just going to perform modulus operation. I am compiling the program and I am moving into the debug session of Keel Microvision IDE. I am just running till this modulus operation right over here. You can see, sorry, I forgot to give enter at the end. So you can see clearly addition operation of 7 plus 5 is 12 has been printed, subtraction is equal to 2 has been printed, multiplication is equal to 7 into 5, 35 has been printed, division operation, that is 7 divided by 5, the quotient value, that is 1, has been printed, and in modulus operation 7 modulo 5, the remainder value is printed. So this is the major difference between division and modulus. When you divide a certain number with another number, the quotient value will be stored in the variable, and if you perform modulus operation, the remainder value will be stored as a result in a variable. So this is the major difference between division and modulus in C language. And now I'm just going to provide \n to all the printf statements for better visibility. You can see the result is same. So this is how each and every arithmetic operations will be performed inside the CPU of ARM Cortex-M processor. You can see here adders will be useful for adding a number, and subbus will be useful for subtracting a particular number. Yes, multiply bb will be useful for multiplying a number. Yes, div is useful for dividing a number, and MLS is useful for finding the modulus of a number. So these are the various kinds of instructions available in ARM Cortex-M processor for arithmetic operations. Okay, now we are just going to demonstrate how the compiler handles expression in embedded C. So let me just delete all these things. I'm going to keep only this. And here I am just going to perform another multiplication operation of A after this addition. So now you can clearly see in this expression we are having two different operations to be performed. So what will be my value of C? So C is nothing but A plus B into A again. So A plus B, we know A value is 7, B value is 5, and now when you evaluate this equation, you will get 7 plus 5 into 7 again. So when you execute this expression first, you will get 12 into 7, 12 into 7, is equal to 84. And when you execute this expression first and then this addition expression, what you will get is, you will get 7 plus 35, that is 42. So what will be my result? So this purely depends on a concept called precedence of operators in C. So most widely, these kinds of operators, not only arithmetic, all the other rest all operators also has one rule called precedence rule. So based on the precedence rule that is available in C language, the operations are performed. That is, among all the operations that is listed out in an expression of instruction, the operation that needs to be executed first is decided based on the precedence rule in C program. And using these kinds of phrases in your program helps us to define user-defined precedence. So precedence of operators are nothing but, as you can see from this table expresses the precedence of all the operators, not only the arithmetic operator but also various other operators precedence. Out of all these, you can clearly see the multiplication, division and modulus of arithmetic operators are having the precedence value of 5, and addition and subtraction of arithmetic operators are having the precedence value of 6. So here the concept is, lower the precedence value, higher will be the priority of execution. So here we are having multiplication with the precedence value 5 and addition with the precedence value 6. So multiplication is having lower precedence when compared to addition. So first the multiplication will be executed and then the addition operation will be executed. So from our expression you can clearly see we are having two different operations. One is addition and another one is multiplication. So what it does is, it will execute the multiplication first and then the addition operation will be executed. So the value will be the same 42 as we derived before. So let me just compile this code, and when I run it, you can see I am getting the C value to be 42. So this is how precedence of operators work in C language. And one more thing, what if I have division right over here? So now you can see the expression is A divided by B into A. So here is nothing but 7 divided by 5 into 7 again. So from the precedence table, you can clearly see the multiplication and division is having the same precedence value, that is 5. So in this case, what you can do is, you can look into another parameter called associativity. So when the expression is having the same priority or precedence based operators in its evaluation, then associativity of the operator comes into play. So this last column right over here is the associativity of all the operators. So when you see here, this multiplication and division from this table is having the associativity of left to right. So associativity is nothing but the order of execution. You can keep it as order of execution when you have the same precedence based operators in your expression to be evaluated. Since we are having multiplication and division, the associativity is nothing but left to right. So the order of execution of the multiplication and division will be left to right. So here what happens is, the leftmost operator is A divided by B and rightmost operator is B into A. So this will be executed first and after the execution result of this will be multiplied with a again. So 7 divided by 5 is nothing but 1 in integer, so 1 into 7 we will be getting 7 again. This will be my result. So C will be holding the value 7. I am just compiling and running this code. You can see C is equal to 7 is printed. So the expected result has arrived. And finally we just lost one thing, that is this equal to operator. So from this table you can clearly see the equal to operator right over here, which is having the precedence value of 15, which is a little bit higher value. So most oftenly this assignment operator, that is equal to operator, is most widely useful for assigning the value on the right to the variable on the left. So this will be having the precedence value of 15, and mostly this will be executed at the end of expression operation. That is, let's take our case itself. You can see in this expression we are having a divided by b and multiplied by a again. So based on the associativity of both these two operators, since it is having the same precedence value, left to right is executed. First this is executed and the result of this will be multiplied by a, and the final result of this expression will be loaded to the variable c using the equal to operator with the precedence 15. Since these two, division and multiplication, is having the precedence value 5, these two are executed first in this instruction C is equal to a divided by b into a, and finally after the execution of expression based on precedence and associativity, the assignment operator will be functioning for writing this expression value to the variable c. So this is how assignment operator is having a precedence of 15. Now let us take the same example. So in this example that we have been discussing, the value of this expression will be a divided by 5 into 7 divided by 5 into 7. So the precedence of this multiplication and division is having the same value, that is 5. So associativity of these two operators will be performing from left to right as we discussed. So this division operation will be performed, and following that this multiplication operation will be performed with the result of the division operation. So this is the associativity of these two operators, right? So now in a special case, let us assume that I need this multiplication operation to be performed prior to the division operation right over here. So what I will do is, I will add a bracket to this multiplication operator, which will provide the high precedence to this operation that is available inside this braces. So b into a will be performed first, and following that with the result of b into a divided by b into a will be performed. So this will be the precedence when you provide braces to any of the expressions in C language. So now what happens is, this multiplication will be performed, and following that this division will be performed. So prior when we divided, we got the value to be 7 divided by 5 is 1, and 1 into 7 we got the output to be 7, right? So when I add braces to this, this becomes the high precedence operation. So 5 into 7 is 35. So 7 divided by 35 will be the result of this, and 7 divided by 35 I will be getting the quotient value to be 0. So this expression will be yielding me the result of 0 to the variable c. So let us check whether we are getting the same result as expected. You can see we got the value 0. So this is how you can change the precedence and associativity in a user defined manner using braces then and there in your expressions of your program. So I hope you learned the functionality or basic functionality of all the arithmetic operators available in C language along with precedence and associativity of the same operator in this video. See you in the next video. Thanks for watching.